Hey everyone, welcome back to Teach Me Now. This is your boy once again coming back with another fire video. Before I even start, I just wanted to say Happy New Year to everyone, hoping that we starting the year of 2024 with positive energy and good spirit. Guys, we didn't forget you. Even this year, we'll be pumping more content for you guys. So our focus today is based on grade 10s, actually. So without waste of time, let's get down to our question. So today we're focusing on number systems. So the question is about determining between which two integers an irrational number lies. So our A is root 12, cube root 50, as well as negative root 28, right? So before we start, let's just define an irrational number, right? Let's just define an irrational number. An irrational number can be a pi, can be a square root of numbers that are not perfect squares, or cube root of numbers that are not perfect cube, right? And an irrational number cannot be expressed as a fraction. So here they gave us square root of 12, right? So which means basically we're focusing on 12. So we're looking for perfect squares. One should be less than 12, the other should be greater than 12, but not just any perfect squares, consecutive perfect squares, right? So here we have 9, and then as well as 16 as our second perfect square. So as from here, remember now, they gave us root 12. So we need to create our root what? 12. So we need to square root all the numbers. So we have the square root of 9 here. We have the square root of 12. We have the square root of 16. And then it gives us 3. And then here we have the square root of 12. And then square root of 16, we get 4. And then as from there, now we can conclude and say root 12 lies between the integers 3 and 4, right? I think we've answered the first question, right? Remember, conclusion is important. So root 50, cube root of 50, sorry. So we need to focus on 50. So we're looking for perfect cubes. One should be less than 50 and the other one should be greater than 50. So we have 27 as well as 64. So not just any perfect cubes, but consecutive perfect cubes, right? And then as from here, remember they gave us the cube root of 50. So we must create our cube root of 50. So we need to write, or actually have, a cube root of 27, a cube root of 50, as well as a cube root of 64, right? Now we've already created our cube root of 50, right? But the cube root of 27, that's 3. Cube root of 64, that's 4. In between signs, and then we have the cube root of 50, which is our main focus, right? Now we can conclude and say, therefore, the cube root of 50 lies between the integers 3 and 4. Perfect. Now we go to C. See, they gave us negative root 28. So our main focus is on 28. So we're looking for perfect squares which are consecutive to each other, but one should be lesser and the other should be greater than 28, right? So here we can have 25 as well as 36, right? And then as from there, we must create our own root 28. So we square root all the numbers. We square root all the numbers. I hope now we understand the idea behind this. So the square root of 25, that's 5. And then we have the square root of 28. Perfect. We are looking for square root of 28. Right? And then here we have 6. But now, once again, we're looking for a negative square root of 28. Right? So we need to say, okay, negative 1 multiplied by 5, negative 1 multiplied by root 28, negative 1 multiplied by 6 equals to. So here we get negative 5. Here we get negative root 28. And here we get negative 6, right? And then our final answer becomes negative 5, negative root 28, and negative 6, right? But now, remember, whenever you multiply or divide by a negative number, the inequality sign changes. The inequality sign changes, right? So, as from there now, we can conclude and say negative root 28 lies between negative 5 and negative 6, right? We've come to our end of the video. This is your boy Mandla from Teach Me Now, signing out.